Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 1210, Introduction to the Sky and Solar System, Lecture 4, Longitude and Latitude. In the last lecture, we saw that how we view the sky depends on our longitude and latitude, and we'll examine that in a lot more detail in Lecture 5. But I thought it was worth taking a moment to talk about what longitude and latitude are and how we measure them. So the first thing I'd like to start with is a learning catalytics question. And that learning catalytics question is, true or false, here in Charlottesville, Virginia, a compass points true north. So this is one where I just want your opinion on this, sort of your gut feeling. So take a moment, log into Learning Catalytics, and answer this question. Does a compass in Charlottesville, Virginia point true north? Well, now that you've answered the question, let's take a look at the answer to this. And surprisingly, the answer to this is that no, a compass does not point true north. So the answer to this one is false. We'll find out here in a second that a compass points to magnetic north, which is different than true north. True north is not the same as magnetic north. True north is the north geographic pole, whereas the magnetic north pole is the location where the Earth's magnetic field comes out up near the North Pole, and the two of them are different by many hundreds of kilometers. And that means that a compass pointing towards the magnetic pole does not always point towards the true geographic pole. I often like to mention to my students that the geographic pole is the pole that you see at the top of a globe. If you have a globe of the Earth, and you see the axis coming out of the top of the globe, this is the geographic pole of the Earth. Another way to know the geographic pole of the Earth is that's where Santa Claus lives, and Santa has his workshop at the geographic North Pole. The magnetic pole, as I mentioned, can be hundreds of kilometers away. It also wanders over time. This is the location of the North Magnetic Pole on the surface of the Earth from about 1900 up until the year 2020. And slowly, over time, the North Magnetic Pole has wandered across the surface of the Earth. And in fact, in the last 20 years, it's been moving very quickly. In about 2018, 2019, the North Magnetic Pole was fairly close to the geographic pole, and it has now moved past the geographic pole, and it is moving further and further south. This is northern Canada over here. This is Greenland. So the magnetic pole has moved across by the North Geographic Pole, and now it is moving down into northern Siberia. The reason the magnetic pole is moving is it has to do with the dynamo deep down inside the Earth and how the Earth's magnetic field is generated. And frankly, we don't understand that dynamo well enough to know precisely why it is that the Earth's magnetic field is constantly moving or changing. But just know that a compass points towards the magnetic North Pole and not towards the geographic North Pole. But for maps and other things, what we are interested in is the true or geographic north. Now, if you look on a map, you can actually see down in the legend down here the difference between the magnetic North Pole and the true geographic North Pole. This is a U.S. Geological Survey map of Charlottesville. Here's the University of Virginia, Interstate 64, Route 29 coming down. And if we look at this legend up close, we see that there are three things marked here. There is a star marking a line, and that is true geographic north. And this map is aligned on true geographic north. All maps are. But it also indicates the magnetic north over here. And it says that as of the time of this map, which was 2016, the magnetic north was to the left or the west of true north by 9 degrees and 41 minutes of arc. And that means that if I had a compass and the compass was pointing in a certain direction, it's not pointing at true north, but it's pointing about 10 degrees to the left of true north. To find true north, I need to go about 10 degrees to the east or 10 degrees to the right. If you're curious, there's another north marked on here, and that is GN for grid north. And that has to do with the fact that in addition to longitude and latitude, another system for measuring your location on the surface of the Earth is the UTM, or the Universal Transverse Mercator System. Now, we're not going to talk about that one in this class, but that is a system where the Earth is also laid out in a grid And that grid, if you're not at a precise location, that grid is a little bit tilted with respect to north, and it shows you that in Charlottesville, at the center of this map, the grid north and true north are off by about 1 degree, 30 minutes of arc. So that is the difference between magnetic north and true north. This is a map of magnetic declination. Magnetic declination is how much a compass deviates from pointing towards true north. If you live along this line right here, which cuts right down through the middle of the United States, magnetic north and true north line up with one another so that the declination is 0. There is no correction, and that's because when your compass is pointing towards magnetic north, it's also pointing towards geographic north. Over here in the eastern half of the country, the magnetic pole is to the left or west of the true pole. And we saw here in Charlottesville that it's a little bit less than 10 degrees. In the western half of the United States, the situation is reversed. The magnetic pole appears to the right or east of the true geographic pole. So, for example, in central New Mexico down here, the correction is about 9 degrees in the opposite direction. Now, unfortunately, this word declination, we're going to see it again later on. Astronomers measure the positions of stars in the sky using right ascension and declination. So I'm afraid that we will see this word declination again, but used in a very different context. So just be careful when you hear it now called magnetic declination. We're talking about how you correct a compass to point to true north. And later on, we'll be using it to talk about celestial coordinate systems. So how is it that we measure our position on the surface of the Earth? Well, we measure our position using longitude and latitude. Your latitude is your north-south position on the Earth, and it's measured with respect to the Earth's equator. The equator is defined to have a latitude of 0 degrees. The North Pole has a latitude of 90 degrees north, and the South Pole has a latitude of 90 degrees south. And your latitude is simply how far you are between the equator and the pole. It is literally if you were standing at the center of the Earth, looking at the equator and looking at your location on Earth, the angle between them in the north-south direction. So here's a map of the Earth. The equator, as I said, is defined to be at a latitude of 0 degrees. The North Pole is defined to be at a latitude of 90 degrees north, and the South Pole is 90 degrees south. So this is a latitude of 30 degrees north, meaning that you are 1/3 of the way to the pole, right? If this is 0 degrees, this is 30, 60, 90 up here. A latitude of 30 degrees is 1/3 of the way to the pole. A latitude of 60 degrees is 2/3 of the way to the pole, and then you've got the pole up there. This is a latitude of 30 degrees south, and then a latitude of 60 degrees south down here. So that is your latitude. It is your north-south position. The equator is the perfect place to start the system of latitude. So the equator is defined to have a latitude of 0 degrees, and it is exactly halfway between the North Pole and the South Pole, the North Geographic Pole and the South Geographic Pole, or the true North Pole and the true South Pole. Your longitude, on the other hand, is your east-west position. If latitude measures north-south, longitude measures your east-west position on Earth. Now, the problem with the Earth constantly turning is there's no obvious place to start the east-west measurement. That is, if you think about the Earth turning, we could pick just about anywhere on Earth to be the beginning of the longitude system. We could pick any particular longitude to be the beginning of that system. Now, throughout history, various longitude starting points have been used. And in fact, up until the late 1800s, pretty much every nation on Earth used their own longitude system. So in England, longitude was measured with respect to the Greenwich Observatory. In Paris, it was measured with respect to the Paris Observatory. Different countries measured longitude in different ways. In the United States, a variety of different longitude standards were used. Philadelphia was used, New York was used, Washington, D.C. was used. Thomas Jefferson made it his lifelong hobby to measure the latitude and longitude of Charlottesville, and he used as his beginning point the longitude of Williamsburg. But that was confusing because that meant that if you were a sailor for Great Britain and you got a hold of a French map, the longitudes on the French map were different than the longitudes on the British map. And so in the late 1800s, in the 1880s, it was decided to standardize the system of longitude and latitude so that there would be a single beginning point for longitude. And you can imagine in the late 1880s, Great Britain was at its height in terms of power. There were British colonies all over the world. And as the saying said, that the sun never set on the British Empire. They had the largest, most powerful navy in the world. And so it's not too surprising that in the end, the beginning of the longitude system was selected to be Greenwich, England, just outside London, at the famous Greenwich Observatory. And in particular, there's a telescope there, a transit telescope, meaning that it only looks north-south and doesn't look east-west, and it's used for timekeeping. This transit telescope marks the prime meridian, or that location that defines 0 degrees longitude. So it runs from the North Pole to the South Pole, running right through Greenwich, England, and anything along that line of longitude is defined to have a longitude of 0 degrees. Now, latitude is measured north or south of the equator. So latitude, these are the north latitudes, these are the south latitudes. Longitude is measured east or west of the prime meridian. So let's take a look here at the University of Virginia. And in particular, let's look at Leander McCormick Observatory, which is the observatory that is on the grounds of the University of Virginia. Its longitude is 78 degrees, 31 minutes, 19.8 seconds west, and its latitude is 38 degrees, 1 minute, 58.2 seconds north. And that longitude and latitude specify precisely its location on the surface of the Earth. To finish specifying it in 3 dimensions, we also need to measure its elevation or altitude. And in the case of Leander McCormick Observatory, it's 264 meters above sea level. If you use Google Earth, you can actually see on Google Earth, in the lower right-hand corner, or depending on which version of Google Earth you're using, you can see longitude and latitude mapped out here in the lower corner of Google Earth. So, for example, here we are on the lawn at the University of Virginia, and as I move my cursor around, you will notice the longitude and latitude changing. So the rotunda right there is at 38 degrees north. This is 38 degrees, 2 minutes, 8 seconds north, and it's at 78 degrees, 30 minutes, 12 seconds west longitude. So that is longitude and latitude. Now, as I said, for longitude, we could have picked any arbitrary starting point. Greenwich, England was picked as the arbitrary starting point for this, but just know that that is a human construct, unlike the equator, which is sort of a geographic point. It's defined as being halfway between the North and South, the true North Pole and the true South Pole. Just as a reminder, longitude, the starting point for that was completely arbitrary. Now, longitude and latitude, of course, have been significant throughout history. When you look at a map of the United States, you see lots of boundaries are on these curved lines right here. And those curved lines are aligned along lines of latitude. So, for example, the U.S.-Canadian border right here, the border between the United States and Canada, is defined to be along the 49th parallel, or the 49th degree line of longitude. The Virginia-North Carolina border down here, so the border between Virginia and North Carolina, is at 36 degrees 30 minutes north. And this borderline between Arizona and Utah, between New Mexico and Colorado, this is along the 37th parallel, or at 37 degrees north latitude. So you can also see lines of longitude coming into play throughout our map as well. So here in the United States, here's central Virginia. So we are at 38 degrees north latitude, and we're about 78.5 degrees west longitude. So that's our longitude and latitude. So let's think about longitude and latitude for a second. In fact, let's do this. In this learning catalytics question, I want you to think about where you would come out if you dug a hole straight through the earth. When I was a kid, I was told that if I dug a hole straight through the earth, I would come out in China. Well, the question is, where would you really come out? Charlottesville is at 78.5 degrees west longitude and 38 degrees north latitude. If you dug a hole that went straight to the center of the earth and out the other side, where would you come out? What longitude and latitude would you come out? So take a moment to answer this question. I think it would help if you did a drawing, but make a drawing of longitude and latitude and see where you would come out if you dug a hole straight through the earth. And answer the question in Learning Catalytics. All right, now that you've had the chance to answer the question Learning Catalytics, let's go through the answer to this one. So if I'm living in Charlottesville and I dig a hole straight through the earth, where will I come out? Well, here's a very simplified diagram of the earth. So we've got the North Pole up here, we've got the South Pole down here, we've got the Earth's equator cutting across the middle. The Earth is, of course, rotating around an axis that goes through the North and South poles. That's what defines the geographic poles, is the rotation axis of the Earth. And when I say that I'm here at a north latitude of 38 degrees north latitude in Charlottesville, this is what I mean. Charlottesville is located on the globe such that it is 38 degrees north of the equator. A better way to say this is if I was standing down here at the center of the Earth, and I looked there, this angle right here, the angle between the equator and where Charlottesville is located, that angle is 38 degrees. I think it's interesting to note that here in Charlottesville at 38 degrees north, we're not even halfway to the North Pole. If we start at the equator, we will get to Charlottesville. Here's the halfway point at 45 degrees north latitude. So that is in the northern United States, is the halfway point to the North Pole. And then we get all the way up to the North Pole up there. So we are significantly south of the halfway point to the pole. So now the question is, if I start in Charlottesville and I dig a hole straight through the earth, and I come out the other side, where will I come out? Well, if I dig that hole straight through the other side, I will come out over here. Question is, what's the latitude of that point? Well, you might remember from high school geometry that if I have two lines, the equator and this line that goes from Charlottesville through the center of the earth to the place I would come out, these two lines cross one another. And you might remember that if this angle is 38 degrees, when you have two intersecting lines, the opposite angles are equal to one another. And that means that this angle also has to be 38 degrees. But here we were 38 degrees north of the equator. Here we are 38 degrees south of the equator because we start on the equator and have to head south to get there. So the answer is, whichever answer it is, 38 degrees south latitude. So just looking real quick at our choices here, it has to be one of these three answers that has 38 south in it. You would not come out at 38 north. Now, what about the longitude where we come out? Well, now imagine that we stand above the earth and we're looking down on the earth. So I've got my globe of the earth here, and imagine that you're standing up here looking down on the earth so that the North Pole is at the center, okay? So that's the North Pole right there at the center, and we're looking down on the top of the earth. There is an arbitrary line, the prime meridian, that defines a longitude of 0 degrees. So that prime meridian is defined to have a longitude of 0 degrees. Here in Charlottesville, we are west of the prime meridian. So of course, if this is the earth, that's north, east, south, wraps around the bottom, and west right there. So we are about 78.5 degrees west of the prime meridian. So that is the location of Charlottesville, Virginia. Now, at our longitude of 78.5 degrees west, if I dug a hole straight through the earth and I came out the other side, I would come out over here. Now, and I should have mentioned that 78.5 degrees west just, again, means that if I'm standing at the center of the earth and I look at where the prime meridian is located and look at where we are, that angle is 78.5 degrees. Now, if I dug that hole straight through the earth and I came out over here, that's where I would come out. And that angle right there is east of the prime meridian. And the question is, how far east of the prime meridian is that? Well, the clue to this is that I have to go exactly halfway around the circle. A circle has in it 360 degrees. If I start here, go all the way around the Earth, and come back again, I do a full circle of 360 degrees. But when I dig a hole through the Earth and come out the other side, I am going halfway around the circle. I'm going 180 degrees away. So to figure out the longitude of where I would come out, I start here and I go 180 degrees. Well, if I start here, I go 78.5 degrees to get to the prime meridian, and then what's left is I have to go 101.5 degrees to get over here, and so that means this longitude is 101.5 degrees east. Okay, and that's because starting here to go 180 degrees, I go 78.5, and the remaining angle that I need to go to make up 180 degrees is another 101.5 degrees east. So the place that I would come out if I dig a hole straight through the Earth is 101.5 degrees east and 38 degrees south. Now you might wonder for a second, and let me use this diagram to point it out, you might wonder why it is that you don't come out at 78.5 degrees east, right? So if you dug a hole straight through the Earth, wouldn't you come out at, and we're at 78.5 west, wouldn't you come out at 78.5 east? And the answer is here is 78.5 east, right? So if you start at the prime meridian and you go 78.5 degrees, you get over here. That's 78.5 degrees east of the prime meridian. And as you can see, that is not opposite us on the Earth. So if I dug a hole straight through the Earth, I would come out at 38 degrees south, and I would come out at a longitude of 101.5 degrees east. So now I hope the question that you're wondering in your head is, where is this? If I dug a hole straight through the Earth, where would I come out? And I want you to answer this in Learning Catalytics. So here's a map of the Earth. You'll see it when you bring up your Learning Catalytics question. Use your mouse, or if you're using a tablet or a smartphone, just tap on the screen. I want you to tap on that location where it is. You'll notice that this is the prime meridian cutting down through here. That is 0 degrees right there. And then, of course, the equator is running right here. So that is 0 degrees latitude right there. So once you know those two things, that this is 0 longitude and that is 0 latitude, use the markers on this map and click where you would come out at 78.5 degrees, at 101.5 degrees east and 38 degrees south. Take a minute to do that, and then we'll talk about the answer. Okay. So I hope you found the answer to this to be really interesting. If I'm living here in Charlottesville and I dig a hole straight through the Earth and come out the other side, where would I come out? We know already the longitude and latitude. It's 38 south, 101.5 east. And the answer to this is that if I dug a hole straight through the Earth, I would come out down here in the southern Indian Ocean, a little bit south and west of Perth, Australia. And we can actually show that in Google Earth over here. So if I bring up Google Earth and I just zoom out a little bit from Charlottesville and zoom out to the east coast of the United States, and then I ask Google Earth to search on 101.5 degrees east, 38 degrees south, and see where I would come out. You will see, again, that it is in the southern Indian Ocean. The southern Indian Ocean, just south and west of Australia. That's where we would come out. That's the point on the Earth. It's called the antipodal point. That is the point on the Earth that is exactly the opposite of where we're located here in Charlottesville, Virginia. Okay. So now that we know where we come out, let's talk a little bit about the poles in the sky. I can take the North Pole of the Earth and extend it out into space and get what's called the North Celestial Pole. And I can extend the South Pole of the Earth out into space and get the South Celestial Pole. And we've already seen from our diagrams showing the Earth turning, or the stars moving through the sky as the Earth turns, that the sky appears to be turning around those same poles as well. If the Earth is turning from west to east, if the Earth is turning from west to east around those poles, and we think of ourselves as sitting still, it's not surprising that the sky turns from east to west around those same two poles, the north and south celestial poles. So how can we find those in the sky? The most reliable way to find the north celestial pole in the sky is to find the Big Dipper. 4 stars make up the bowl of the Big Dipper, 3 stars make up the handle of the Big Dipper, and these 2 end stars are called the pointer stars, and they point right at the North Star Polaris. It's the most reliable way to find the North Star. Now, the North Star Polaris doesn't sit exactly at the pole. It's a little bit less than a degree away from the pole, which means when you look at those star trail diagrams, you'll see that the North Star does make a little tiny circle in the sky. But for all intents and purposes, Polaris is marking the North Pole up there in the sky. Now, as the Earth turns, the Big Dipper is rotating around Polaris. As we look at the northern sky right here, the stars rise in the east, move across the sky, and set in the west. So everything in the northern sky is moving counterclockwise. But the pointer stars will always point at the North Star Polaris. In the southern hemisphere, it's a little bit harder to find the south celestial pole, and the reason is that there is no bright star that marks the south pole. Probably the best way to do it is to find the Southern Cross in the sky, and then go out a few hours later and find the Southern Cross again. And if you use the upright bar of the cross, the vertical bar on the cross, and remember where it was pointing in the sky, and come out 6 hours later, say, and look at it again, those two will intersect at the south celestial pole up there in the sky. So the South Pole does not have a bright star. Once you have found the North Star Polaris, the way to find true north is to just drop a line straight down. So once you have the North Star, you just drop a line straight down, and this is an azimuth of 0 degrees. That is exactly due north on the Earth. Just like we can extend the poles out into space, we can extend the Earth's equator out into space, and we get the celestial equator. The celestial equator is a ring running through the sky that is simply the projection of the Earth's equator out into space. And the celestial equator hits the horizon due east and due west. But we'll see more of this in the next lecture coming up. In Lecture 5, I'm going to introduce the idea of the celestial sphere. We've talked about the sky appearing as a dome over our heads. We've talked about the north and south celestial poles. I've now introduced the celestial equator. So let's take that dome over our heads and imagine it being a full sphere, and we call it the celestial sphere. And in the next lecture, we will examine the celestial sphere and learn all about it. So I will see you in Lecture 5.